Preventative fraction. Right then, let's go into other names. It is also called relative risk reduction. Now then, this is a tad confusing, and I will state why. So, what is it? Risk difference percent before. This was to try and find out how much the risk or rate in the exposed is due to the exposure by taking the unexposed group's risk or rate into consideration. However, what about a protective effect? So, the change is simple. This is for when the R1, the exposure, has a lower risk or rate than the to the exposure compared to the non-exposed. So this is for, let's say, a new type of intervention. So maybe a new intervention that's meant to go and prevent diseases, and you want to go and prevent cholera or whatever it is. You want to see if it's actually having a protective effect. So intervention, type of surgery, or just an area in an ecological study. So the calculation is quite literally the mirror opposite of the risk difference in percent that you've seen before, which is the attributable proportion, risk difference percent, attributable fraction, or attributable risk, or the other names that it goes by. It's literally the exact opposite. So, in explanation to this, what it's actually showing, let's say the R1 in the attributable proportional risk difference, the R1 is the exposed and it's a risky group, minus the non-risky group divided by the risky group. In the preventative fraction, it's the non-exposed or the risky group minus the exposed, which is the safer group, divided by the risky group. Exactly the same as the risk difference above there. But it's because the R1 is exposed and the exposure is something good, you have to flip it around. So then, let's give you an example. Question of how much of a protective effect does being in area B give you, for whatever reason. Okay? This may be because, let's say it's cholera, and we've got a water company that is doing better filtering of its water, so hopefully less cholera cases. And we're calculating this to go and see if there is a definable difference. But maybe the waterworks isn't 100% at cutting out all the cholera from filtering out all the cholera. So we've got the little table that you're familiar with from before. Now, R1 exposed, R0 unexposed or non-exposed. Now let's flip it around again, where the exposed actually shows the risk per one person, which is less than the unexposed, right? So 0.04 to 0.1. Now, you'll remember I did exactly the same thing in risk reduction when I showed an example of the exposure being the good thing. So this is just risk reduction where there's a before, if you remember, there was just a negative difference, correct? This is just where you plug that number in exactly as it is, and you just divide it by the unexposed. That's all it is, as you see here. So then, the preventative fraction, you just chuck all the numbers in. Dun, dun, dun. You can go and believe me or calculate it yourself, but it calculates this. You have another calculation that you can do also, 1 minus the risk ratio. Here is the risk ratio as it is. Creates this, et voila, done. So then, what does this number mean? Again, the question is how much of a protective effect does being in area B give you? So the preventative fraction is 0.6177. So the interpretation is whatever was in area B has prevented its case numbers being 62% greater. Or 62% of the cholera cases that would have occurred in area B were prevented by being in area B for whatever reason. Now that's just that's just an interpretation that's just flipped on its head there, and it's another way of looking at it. But both interpretations are completely valid in this situation. And again, whatever was in area B has prevented its case numbers being 62% greater. This is by taking into consideration the unexposed, or 62% of the cholera cases that would have occurred in Area B were prevented from even occurring by being in that area for whatever reason. So, that is preventative fraction. Thank you for listening.